Whether you are looking to build a new career or kickstart that new idea that you've got,
Microsoft Reactor connects you with the developers and startups that share your goals.
Learn new skills, meet new peers, and discover the latest in technology.
Events are running around the clock, so join us anytime, anywhere.
Reactors are communities to connect. We want you to meet real developers and entrepreneurs just like you. Here you can get skilled up and learn from our product experts in the Microsoft Cloud and in open source. So watch us on demand and share your own perspective as we live stream in communities all around the world.
Hello, everyone. Good morning, good noon, and good evening to all the people who all are joining us globally. I am Parth Varu, event planner at Microsoft Reactor Bengaluru. Thank you for joining us today. Oh, yes, we have our season 4 back. So I'd like to welcome Vivek and Nish. Hey, Vivek. Hey, Nish.
Hey, how are you all
Nish,
doing?
hey
It's a
Parth.
new season, new year.
Yep.
Yep.
By the way, that video was really amazing. I didn't. That's the first time I'm seeing that video. That looked cool. Is it the new video that we're gonna play now rest of the year?
Yes, we're gonna play.
Yes. That's an amazing video, right? Amazing
Yeah.
video edit. I know you will definitely recognize that video because you love editing.
Yeah, it was like feeling so pumped, looking at this. I just want to learn something new today. It was so good.
Yeah, that's true. Yep, we are back. Back after celebrating 1 year of Somersetchai.net in December. So it was fun meeting people in person as well. This was really good. So Nish,
Yes.
so what we have today
I
at
think before that,
Somersetchai.net
let's
show?
let's do some housekeeping. Parth has
Oh
some
yeah,
some important information to convey. Go ahead, Parth.
yes.
Yeah. So before we begin, let's do a code of conduct. Please take a moment to read our code of conduct. We are all here to learn together. So please be respectful of other people's views, understanding our differences, being kind and considerate in the way you all engage. Obviously, we do encourage you all to participate. Please ask questions. To ask questions, drop all your questions in the comment section. Over to you, folks. Let's begin the session.
Thank you, Parth. Cool. All right, Vivek, what's up? What are we learning today?
So yeah, today we are going to learn gRpc. I'm new to this. Okay, I have never done a development with gRpc, and I purposefully did not look into internet to understand all the things it is related to. I know in the bits and pieces what it is and all the stuff, but not really gone in depth. I'm being a REST guy, right? It's an API building REST API, so I never done a development into that. And when Tulika told me about, yes, we will do this, then I didn't deep dive. I'm just waiting for her to teach me this today. And
That's
yeah,
yeah, that's the best thing to do, right? I mean, samosa chai and some gRpC. So welcome, Tulika. Hey, Tulika. Good to see
Hi,
you.
good to see you
Tulika
too.
is Tulika is
nice.
my longtime friend. We have been doing some community events for a very long time. How many years ago was it, Tulika? Like we used to do events at B.net?
Yeah, it has to be at least 10 years.
10 years
I
is
mean,
too.
COVID,
I'm pretty sure it's
COVID
15 or
ate
16.
away like 2 or 3 years. So who knows? We never count those.
That's true. Yeah. So go ahead and tell us what you do now. And I know you work for Microsoft, but let our viewers know what you do right now, and then the specialization you're going to talk about today.
So I've been with Microsoft about 18 years. December completed 18 years. I
Wow.
work as a PM for the app services team, specifically for Linux app services. And I used to be .NET and I used to be really passionate about .NET. But now, my heart is more with app services. Sorry, Nish. But, we're going to do some .NET and some app services, and hopefully it's going to be a fun session.
And
Not all the
this is
way.
the we knew that we knew that. So that is why we have got you here, so that we want to evangelize .NET to you.
That's a good
we
thing
want
too.
to we want to bring you back.
Tulika, for those of people who are first time hearing that word Azure App Service, because you said like you were .NET and now you're App Service. Go ahead and tell us what exactly is an App Service.
So, App Service is the Azure PaaS offering. Just a spiel for ourselves, it is in the first three most used services of Azure. It's a PaaS offering, which means that once you deploy your code, it is the responsibility of Azure and Microsoft to make sure that everything runs. We take care of the VMs which are working in the background. We do automatic updates for you. We will make sure that everything works for you. So basically, it's almost like BYOC, which is bring your own code and we will run it for you. And we'll look at it in the session. You'll hardly need to do any changes in your code at all to run it on app services.
Amazing, amazing. So what that means is like I can take my existing .NET code and then just bring it to Azure and say like, okay, deploy this for me, and it's just done, right?
Yes, that's the magic.
Fantastic. So I'm going to bring in your slides in, and then let's talk about the topic today. I think you're going to talk about gRpc with .NET Apps. As Vivek mentioned, he's totally new to gRpc. I know that gRpc is just a fancy word to add to the resume. You may want to prove me wrong. Uh, and tell
I
us
don't
why.
think so.
So go ahead and tell us why gRpc is important, and why are we speaking gRpc in 2023?
Um, I can't move the screen. Okay, I can. So we are going to talk a little bit about the agenda. It's going to be very loose. I don't think we're going to exactly stick to it, but we're going to talk about what is gRPC, try to build a local gRPC client and server because we always want to test locally, understand a little bit about app services, and then deploy our gRPC server onto app services. So very straightforward as far as the agenda is concerned. Now there's a lot of text on this screen and it doesn't matter. But basically, what gRPC is that it's a framework, it's an open source framework, which allows a client application to talk to a server application as if the server application was not running on a different machine, but is running locally on the client itself. Now, we've always had ways to call server applications. We had RPC, which was called remote procedure call, by which we could call applications remotely. Some of you, if you've been for a longer time with Microsoft, you also probably have heard about WCF, which allowed you to do the same thing. The only thing that gRPC really does is that it gives you a kind of a protocol or a framework which allows you to call services with different technologies. So potentially you could have a client which is running Java and you could call a .NET service, or you could have a .NET service call a service which is running in Python. So it just allows you to have different technologies together which could talk to each other. And that's why gRPC has become so very important in the whole microservice landscape. Now, some of the things which is specific or characteristic of gRPC is, firstly, a little bit of history. You may be interested, may not be. gRPC started in 2015. This was a Google project where they wanted a way to link different microservices in their internal infrastructure so that they can talk to each other. They released it as an internal project and it was supposed to be for the internal infrastructure, but very soon they were able to standardize it and release it for community use. And almost immediately on its release, it became really popular with the community. And now gRPC is powering use cases like microservices, web, mobile, IoT, any kind of applications that you can think of. Uh, some of the other characteristics of gRPC is that it relies on something called protocol buffers. So at its heart, gRPC is basically something which allows a client to talk to the server, and a way of standardizing this is by using protocol buffers. A protocol buffer is a way in which you serialize data which is going to be passed between the client and the server. So essentially, what it's doing is it's defining a way to do serialization between the client and server. It essentially is just something called a proto file, and we look at a proto file when we create a project. It's just a text file with a .proto extension. All the text file does is it defines a logical record of information, which are like name value pairs, which is the parameters you're going to pass back and forth. Google has also provided a compiler, a proto-buff compiler called Protoc, which automatically compiles the proto file and generates the server and client stubs that we are going to be using. So now the server, all it needs to do is it has to implement the interface, which you've defined as your proto file, and implement a method which listens for client connections, while the client just has the stub and therefore is able to call the remote methods. The other characteristic of gRPC is that it's built on HTTP2. And again, it's a whole framework, so I'm not going to go into details about it, but it's so much better than HTTP 1.1. There are a lot of benefits to HTTP2. Some of the benefits are that it uses binary protocols instead of the textual protocols that HTTP 1.1 uses. Therefore, it's much faster. It has better compression mechanism. And some things that really is exciting is it allows multiplexing, which means that on a single connection, a single TCP connection, you can send multiple HTTP requests. And the second thing which is interesting is that it allows server push. So an HTTP2 server can push content onto the client's browser cache even before the content is actually requested. So which means that your client can have content which without even requesting for it. gRPC is built on HTTP2, which means it automatically takes advantage of everything that HTTP provides out of the box without having to do anything.
Yeah, Tulika, just 1 second. Sorry to break you off your trace of thought. There's some microphone disturbance that's coming in. I don't know if it's to do with your mic, which is trying to adjust, because we just hear from Arun saying it's getting more disturbances from you, and I can hear too. Like it's something. Yeah, try not to move that, because I think what's happening is when you're moving, it's just rubbing
Oh,
against
okay.
maybe the
Okay.
the the yeah.
I see. Sorry about that.
Yeah, yeah, good.
Cool. I mean, I think I got a fair idea now. So this basically it works with multiple languages. So if you want to make a call to multiple languages, and you could use same protocol. And interesting topic is protocol buffer. Probably we need to go deep dive into that in next few couple of shows. Probably, Manish. I know it is going to be interesting, but I know today's it's not just about gRPC. So that will be an interesting topic. But yeah, it is about building the structure. So it is basically it is directly talking to the server, and it's a direct connectivity, and there is no much of a hassle in terms of calling stuff. Yeah,
Yeah,
and then support for HTTP2, which is again from the performance, load balancing, monitoring stuff, streaming kind of a tool. If you are building those kind of support is there. So yeah, I mean I pretty
and
much summarized, right?
yeah,
Summarized it.
and did you hear her say about WCF?
Yep.
Uh, that's have you heard of it?
No.
so that's something which I was used to before REST, which is the contracts first API, where in WCF we used to have that. We define an interface and then we start with having the contracts, and it's really cool to kind of like define that and then go through that. And it's nice to see that we now with gRPC we have this polyglot uh, kind of scenario
Yeah.
where we can work with any systems where as long as you define the contract correctly. Cool. Tulika, take it away.
So I think we have done enough theory. We can start with building a gRPC client and server. We're going to use Visual Studio because we are using .NET. And the good news is that Visual Studio provides almost everything out of the box. So we'll just see how simple it is to do it. And I know Nish is already smiling like, this is my work. So let's go ahead and start creating a project.
So to really kind of like appreciate that tooling support in Visual Studio, you got to really do it without it to understand that, like how difficult it is to set up the. I'm pretty sure there are other toolings out there which makes it easy. But yeah, I mean, because I've been working in Visual Studio for past maybe around 18 years, as you said, so yeah, it's something which is really, I love it. When the tooling gets better, we just become more efficient.
So over here, I'm going to basically follow this tutorial, which creates a gRpc client server, and you can test it out. If you notice over here in the tutorial, you can try it with Visual Studio, or you can even use VS Code. You also have Visual Studio for Mac instructions. I'm just going to go ahead with Visual Studio 2022. So let's start up. So I'm going to start with creating a new project. And now again, you don't actually need to do it like this. You could build everything by hand, but it's better to use the scaffolding which VS already provides. So I'm just going to search for gRpc, and you see over here that we have a templated project for gRpc. So I'm just going to use that. And we can name it whatever. I'm being true to the tutorial, so I'm naming it exactly the same. gRpc support is enabled for all versions of the .NET framework. However, over here, we are going to use greatest, so we are going to use .NET 7. Now, as you can see, the project has automatically got created, and you can see a number of files which got created over here. The first thing is what you want to look at. Remember how we spoke about protocol buffers? So you have the protos file over there, which is the .proto file. You can open this file. And as I had mentioned earlier, this is just a text file with a .proto extension. All it does is, of course, this is your namespace, but it defines the methods that the client and server are going to be used to talk. So it defines there's a hello request and a hello reply, which are just generic methods, which it's defined. Because right now, remember, we haven't created any kind of logical record or data, so that's why we have some generic methods in the proto file. There are certain other files which is interesting. So let's first look at the services. So I mentioned earlier, gRpc is nothing but a service definition. So you have a service, and if you look at the services file, it has, I mean, this is just the constructor, and you have a method called say hello. Again, this is the Visual Studio scaffolding, which has just generated a method for you. We can modify this method or create new ones. Right now, I'm just going to write some text just to, prove to you that this is our method. So we have this service which is running automatically there. Let's go ahead and look at program.cs as well. So in the program.cs, we are using the normal ASP.NET builder. We are adding the service to our builder, which is the gRpc, and we are setting it up to run. So again, very standard ASP.NET code. The only difference is we are adding a specific service called gRpc to it. And let's also just take a look at app settings. As I mentioned, gRpc runs on HTTP2. So we are specifying the protocol over here for HTTP2. You can run gRpc using any of the other web servers that ASP.NET provides. For example, you could use IIS if you wanted to. You could use http.sys, but keep in mind that those are very specific to Windows. So if you're running it on Mac or any other OS, that might not work for you. Kestrel is what we recommend. So it says for Kestrel, we are setting the protocol to be HTTP2. And finally, there is another file which is called launchsettings.json. And you will notice that over here, we have specified what is the application URL that you're going to use. So basically, it works on localhost because first we are going to try on localhost, and it also specifies the port that we are going to use. So in this case, we can either use these two ports, but right now, since we are using development environment, we'll go ahead with 5121. You can run this right now if you want to, and that's just going to automatically build things for you. I started without debugging, so
So Tulika, there's a question from if you go back to the program.cs file. Um,
mhm.
I have one question for you.
Okay.
So, so you're using NuGet package, right?
Correct. So what the
Is it
scaffolding
built?
does for you? Yeah. Sorry, go ahead.
No, it is by default. It is available, or I need to install something, or how
So
is it?
you could install if you were creating like a service from scratch. And so you could, if you go back to the slides, I've mentioned the packages you need to manually install and do an npm install for those packages. Since we use the Visual Studio scaffolding, it automatically installed the packages for you. So you don't
Got it.
need to have any other packages.
Got it.
So over here, you can see that my gRpc server has started, or at least my server has started. We can go ahead and browse this URL. What do you think is going to happen if you browse it though?
Vivek, it's a question for you.
Oh, it's question for me, is it? I thought it's for audience. I am the audience. Okay.
You're the one who's learning right now.
Yeah, yeah. It should call the client should call the server.
Actually,
It
it
does not.
basically does not, because current browsers support HTTP 1.1 by default and not HTTP 2. Remember, earlier I mentioned that gRpc is built on the HTTP2 framework, which means that this from a browser, this is not going to work. This is for client and server communication, so you have to have a client which calls it. But at least we know that the server is working because right on the, like, this is the message that we've set up. So, at the very least, proof of
Yep.
concept it is working. Okay. So now let's go ahead to the next step, and we are now going to go ahead and try and make a client.
Tulika, before we get there, were some more questions. I think we can take it from the audience. Arun is asking, is it based on the old .NET remoting technology?
No, it is not. So when we use the gRPC, we've taken the entire framework from Google, which means that if you go and look at some of the dependencies out here, and you can see that we are directly using the protobuf compiler and things which are provided by Google itself, rather than building our own tools or own standards. We obviously have some tooling in place to make sure things work, but we are basically taking the framework from Google.
Yeah, and there's another question. If it's done in C sharp, yes. Right now, what you're seeing in the demos are all C sharp, but you can do it in any language as well. As long as you have this protobuf, you can make use of the. I mean, protobuf is the kind of like how do you say it? Like it's language agnostic. It's a language. It's a definition by itself, which you can use it in any other language too. Go ahead, Tulika.
Okay, so we're going to go ahead and create a client as well. So I'm going to start another instance of Visual Studio and create a new project, but this time I'm going to create a console project. So we're going to just take a console app.
I know I'm seeing some more questions come in, but I'll ask at the right stage when
Okay,
uh yeah, so that it doesn't disturb your demo.
sure. Again, over here, we're choosing the framework to be .NET 7. It doesn't need to be. You can use any other version of .NET. You can even use, as Nish mentioned earlier, you could create a client in Python or Go or Java to call the service.
Yeah. And I think what Tulika is trying to do here is basically creating the client and server. So she already prepped the server up, and there is a port open. Now it's ready to listen uh, to your requests. Like any client can connect. So now she's building the client out, and she's doing it again in .NET. But you could do it in any other language if you want to. Cool.
So over here, the one thing that we wanted to do was, or what I had mentioned earlier was that we had the protocol buffer. So the protocol buffer is implemented by the server and it is used by the client as a stub to call the server methods. So we need the protocol buffer in both the projects, the client project and the server project. Now I could create a protocol buffer over here. Instead of that, I'm just going to copy it from here because we were just doing a simple one. And again, you don't need to do that. You could create your own protocol buffer. So I'm just going to go ahead and create a new folder. So this is the same protocol buffer that we were using. I'll change the namespace because this is my client now. So that's my protocol buffer, which is already defined. Now, we need the gRpc tooling or the gRpc packages to be able to do anything. We can do an npm install, and I think that was a question earlier. Can we do an npm install? Absolutely, we can do that. But the easier way to be just go to the project and
You
say,
mean NuGet, right?
yes, sorry, you get.
I know you're too much away from .NET these days, but yeah.
So you can just go ahead and add a service reference. And you can see that we have certain service references available. So we'll just do gRpc and do next. Now it's asking what is the file for which it's going to add the service reference. And this is going to be our proto file, the one we copied earlier, because it's going to generate the service file based on that. So we'll go over here and add our protos file.
Yeah, there it's installing the packages.
We can go and look at our dependencies again over here, and you can see the protobuf, which is the Google compiler. For the proto, we have the gRpc tools and the client factory has been added. So from a project standpoint, we're set.
Cool.
You had a question, Nish?
No, good.
Okay. So now we have to do something to call the server, right? So because we've defined the client, we've defined the packages, we've defined the proto file, we actually now have to make the call. So we can go over here in our program.cs. Another thing, just want to mention that it automatically added your protobuf, which is the file you included, which is Visual Studio automatically doing this. So now let's go to our program.cs, and we have to write the code. And instead of writing the code, I'll just copy it. And now Nish is going to say, why didn't you use the snippets? We provide code snippets. Yes, we do.
No, I also feel comfortable using Notepad sometimes. So
So over here, there are two major things that we're doing. We are creating a gRpc channel, which is where we are specifying the address that we need to call for a gRpc server. And using that channel, we are creating a gRpc client and then calling the method on the server. Now, the first thing is for the address, you have to specify the actual address that the server was listening to. So if you go back to the server and you go to the launch settings, remember this was the address that the server was listening to. So that's the address we need to use. And again, because this is just scaffolding, it has already called the hello async method. Remember, this was the method that we had defined in our creator service. the say hello. So it is automatically calling this message. So ideally now what should happen is we should run the server, which will then start listening on the port that we've specified. And we should then call the client, which should now connect to the server and get the message from the server. So that's the outcome we expect. I'm just going to go ahead and add some, you know, some extra information just to make sure that we get some extra logging. You don't need to do that. It's just convenient. And now we can go ahead and launch the server first. And as soon as I get my mouse back, so you can see that the server has launched. Go back to the client. So now, ideally, now we are doing a real gRpc call, which means ideally we should get response back from the server. So we can do a control F5 over here.
Yeah, so the whole greeter.greeter client, that's something which is automatically generated for you. The tooling has done that for you. Basically, what it does is it looks at its protobuf file and then creates the C# classes for you to call it like a local method. But technically, when it is running, it is not making a local call. There you go.
And we can go back and look at our server code over here. And since we added the extra logging for the middleware and the information messages, you can see that it has actually executed the say hello method from the server and it's got back the HTTP2 response.
Right. Cool.
That's
easy.
that's a simple, yeah, pretty easy.
So,
So,
Vivek, you learned
so
everything about gRpc.
yeah. So the verification of these, the photo file, right, happens at the compilation time, is it?
Yes. So remember how we included the Google protobuf? It has actually uses a protocol compiler called Protoc. And the purpose of the compiler is it goes ahead and reads the proto file. It generates the server and client methods for it and loads the schema in memory. So which means that now when the client and server want to talk to each other, the schema is available in memory and it can serialize the data back and forth.
So that's why it is performance. I mean, it improves the performance
Correct.
because it's in the memory. Perfect. Yeah.
Nish, I wasn't watching the chat if there's any question.
Anish, you are in mute. Yeah. Let me read out the question. What gRPC add on top of normal RPC?
So when I say that gRPC is an extension, it's in a sense a whole new framework itself. So it is an open source framework. RPC was very specific to the kind of technology that you wanted to connect to. So RPC typically will, like if it was Windows RPC, it would only work on Windows Server, had very specific ways in which you can connect from the client and server. It did not have anything which could be generalized. It was extremely specific to the kind of technology, the kind of client and server that you were using. gRPC tries to take that away. What gRPC tries to do is make sure that you can use any operating system. So you could be running on Windows, Linux, Mac, anything. You could be running in any technology, and you could just talk to each other without knowing how Python works or how Java works or how Go works. You don't need to know that. As long as you have the protocol buffer file, you already have a service definition and you basically just call using the service definition. It doesn't matter where the server is running, the server will still be able to process your request. So that's what gRPC does. RPC was extremely specific to the technology and the OS it was running on.
Right. And there's another question which says, why to use gRpc? I can still achieve this with web service or REST service call. It's a very valid question, but there is obviously there are reasons, why you would use a gRpc over REST. Yeah.
So you can, and to be honest, I don't think REST is going anywhere. So I think that gRPC will exist together with REST calls. You can still absolutely use REST. If you know where your server is residing, if you want to only use HTTP 1.1 and not take advantages of HTTP 2, absolutely go use REST. However, if you do want to take advantage of the benefits which is provided by HTTP2, and you also want to take advantage of some of the benefits of microservice architecture, then gRPC is the way to go. So in my mind, REST and gRPC are things which exist side by side rather than one replacing the other. Nish, in case you want to add something
Yeah.
to that.
Yeah. So yeah, I can add a few points here. So one of the things gRPC you would use is for performance, because you have everything is transmitted through binary. So naturally they are high performant in nature. And of course Tulika mentioned about the natural benefit that you get from HTTP2 and then now with HTTP3. So you have those advantages coming in. And For service to service communication, this is where, if you look at now with microservices, everything is going distributed in nature, and you don't need to have these REST for just do a service to service communication within the services that you're very much aware of. What you do is you basically have a proto file shared across your services, and they work really really fast. So that way you get faster performance for all the distributed applications in nature, right? I know when we build some of the services, we even though we have gRpc, we also have a REST as well, to support those systems where REST is important to those systems. So now we even see it at reverse proxy level. For example, I think Envoy has this thing where you do all the internal communication through gRPC, but it can actually, from a reverse proxy, it can expose a REST endpoint for you. So it will do the transfer, um, um, uh, you know, change of things, and you still can support both the formats and things like that. There's a few big advantages when you, especially with microservices, where service to service communication is like more than just client server. It's more about too many clients working with too many interdependent components working together to just make one action completed for the user, right? So that's why you get those benefits. Are there any other question? Okay, this question, not sure what how the say hello to say hello async transformation is happening. Did you have async separately?
Um, so are you talking about?
Yeah, I'm not sure the
So
so the
this, I
methods.
mean, by default, all the methods that we use in gRPC is by default it is async. Like we
Correct.
could make it sync by adding some things to it, but by default everything is async.
Yeah, I'm just trying to understand. Like he probably saw say hello async. Is there anywhere in your client which says say hello async?
Yeah.
Oh yeah.
Okay, that generation basically that's what is the slide line number 8. So in your server it is basically say hello, but you in the client you have say hello async, right? So that's what he's asking.
Okay. So this is automatically part of the whole proto buffer tooling, which automatically compiles and makes the methods. All the methods by default, if you're using protobuf or protalk, will be async, which
Yeah,
means that anytime you do a call, you automatically do the async, and the compiler is going to take care of making sure
yeah,
that the call goes to the right method.
yeah. And also I think so one thing you have to remember here is the client doesn't know anything about the server implementation. So server can have a completely different name there. So client is generating this based on the protobuf file, which has a method say hello. So it wants you to use it asynchronously. So it's actually adding that. So it's just a method that was generated by the client. But internally, it will make an RPC call to the exact say hello method in the server. Okay, cool. We can go ahead, Tulika.
Okay. So we already saw the demo. Now we come up to what is app services. I mentioned earlier that this is our platform as a service offering that we provide with Azure, which enables you to create web applications or mobile and or API applications really easily. It's optimized for web application. And basically, as a user, all you have to do is you have to deploy your web app as a code. We even have offerings where you can deploy it as a container, and we will manage the runtime and the environment for you. It also provides benefits like we can do auto scaling for you. So if you get a lot of requests and you automatically want the service to scale, we can do load balancing for you. We can let you run diagnostics out of the box. So it is a full-blown PaaS service, which gives you all the benefits that a global PaaS service can give you. Now, I'm just going to go ahead and look at the portal for app services. So this is the Azure portal. And if you have subscriptions, created some resources in Azure, you're probably familiar with the portal. I am at create a resource. As I mentioned, it is one of the most used services on Azure. So you see it right at the top of the list. And you can do create a web app over here. This is a standard way in which we create any Azure resource. So the first thing that you specify is your subscription. And if you've used the Microsoft credits or you have your own subscription from your company, you will already have a subscription loaded over here. We can create a new resource group. A resource group is nothing but a collection. It's a virtual collection of all the resources that you have. So typically you'll want to have your database and your app and API all in the same resource group ideally. You can create a new one or you can use an existing one, and I'm right now just going to use an existing one. The only thing that you really need to specify is your web app name. So you can give it anything, and I'm just going to say gRpc creator server. So that's the server we want to deploy. Notice that here we give you several options. So we give you that, do you want to just deploy your code? You don't care about anything else, you just want to deploy your code, and that's fine. We also give you for more advanced users. Let's say you want to take advantage of Docker and run your service as a Docker container. We will allow you to deploy your own Docker container. And you can also create a static web app. And I think Vivek will do a session on static web apps at some point of time. So you can choose your runtime stack. In this case, I'm just going to go with .NET 7. You can deploy your app on Linux or Windows. And I'm going to choose Linux for the moment.
Yeah, Tulika, just a quick, because now that you're choosing Linux, there was a question, so I think we can address that right now. The question is, can we deploy gRPC service on Ubuntu 20.04 server?
So we are using Ubuntu servers. I've forgotten which is the exact version which we are on. So this is automatically on Ubuntu. I can come back to you on the version for it, the exact version of Ubuntu we are using. You can deploy it anywhere that you want to. So you don't have to use PaaS. If you wanted, you could stand up an Ubuntu VM and deploy your service on that. The only disadvantage would be that you have to manage the VM for yourself. You have to make sure that it has the right .NET version, and you have to make sure that you maintain it. But it can run anywhere that you want to.
Right.
If you scroll down a little bit, you'll see something called pricing plans. So this is how much we are going to cost, and you could just use the existing pricing plans, or you could look at our pricing plans that we have available. And you can see that we have various pricing plans. We have the shared environment also. So we have free. You could try free, and it's free for your lifetime. So you could take advantage of the free option. We also have a shared environment if you want to use dev for dev and test. As you can see, it's really limited. For example, you just have disk space of 1 GB. But if you just want to test and see if things work, this is a good option. And then we get on to the basic, standard, premium, which depends on what kind of application you're running. If you're running something which is reasonable load, and it's hard to classify how many requests, but something which is not too many and doesn't load your server too much, you could go with the basic environment as well. Now, keep in mind that basic is generally a single core machine. So, if you have a high request website, you probably want to go to standard or premium. So you can choose your app service plan or create a new one. And right now I'm running on the premium plan, and I'm using a single core VM over here with 3.7 GB memory, which should be enough to run my application. The next tab over here allows you to configure CI/CD. So in case you want to have your code residing on a GitHub repo and you automatically want to make sure that everything gets synced, you can go over here. You can say that you want continuous deployment. You can choose your GitHub account and choose your repo from which you want to deploy this. We're not going to do this because we're going to take advantage of Visual Studio deployment at the moment, so we won't worry about this at the moment. And there are a number of other things. Um, these are more advanced things. For example, if you can configure some networking options. If you want to set up your private virtual network, you can do it over here. This is a basic app, so we'll just say review and create. So when it says it's going to initialize a deployment template for you, it's basically creating a template which is going to go ahead and deploy the Azure resource for you. When it deploys the Azure resource, it is a PaaS. So your app is going to run on a VM. So not only does it create an app for you, it will also create a VM for you on which the app is going to run. Internally, since we are doing Linux, internally, your app is going to run in a Docker container. So for Linux app services, all code that you have is going to run inside a Docker container. But again, as the user, you don't need to be really concerned about it. That's how we internally manage it for you. You could just go ahead and deploy your code, and we'll make sure that Docker starts up and the files get created and there's a startup command and all the good things of Docker. And we can now go to the resource. And we can hit browse. And this is a standard page which says it's .NET. We obviously don't have code over here, so this is just a landing page which says, oh, you haven't deployed yet. You should go ahead and deploy something, which is good, fine. So let's stop this. Now, we have to do certain things to make sure that this web app works for a gRpc server, because ultimately that's what we aim to do, make sure that this works for a gRpc server. So we can go over here and go to configuration. And you have two settings over here, application settings and general settings. Let's go to general settings first. Some of the things that you see over here, it's .NET. That's the application we want to create. It is using .NET 7. You can change it whenever you want to over here. We're going to change the HTTP version to be 2 because remember earlier I said gRpc is built on HTTP 2. We are also going to use HTTP proxy. Now, we'll talk a little bit more about the architecture of app services and why do we need an HTTP proxy, but for the moment, let's just turn this on. Don't worry about this. This is not us. And we are also going to add a new application setting, which is called HTTP 2.0 only port. And we are going to use the same port that we have specified in our launch settings.json, which is by 1-to-1. Now, why do we need this? Let's set it up and then we'll talk a little bit about it. So I'm going to just save these settings. So we need it because, as I mentioned earlier, that when you deploy the code for us, we are going to run it as a Docker container. Within that Docker container, it's going to run .NET, but it's also going to run Kestrel. And Kestrel is the one who is actually serving your request. So you need to tell Kestrel which particular port it needs to listen for client requests. So therefore, we are specifying the app setting for HTTP 20 only port and making sure that Kestrel knows that it needs to listen on by 1-to-1. I also want to mention that we have certain changes in the works where given our next deployment, which is in the next month or so, you wouldn't even need to do these settings. So if you deploy from Visual Studio, it will automatically do all the tooling for you and you wouldn't need to do it. But right now, the way things are, you have to make a couple of these changes. So this is deploying over here. When you make an app setting change, it's going to restart your website to make sure that the changes are taken in. When you set a application setting, basically what it's setting is an environment variable. And to set an environment variable, you need to restart the process. So now let's go back to our server. Now, between the client and server, we have to deploy the server on app service because the client can run anywhere. So the server has to be there on app service. So let's go ahead and publish it. And again, Visual Studio makes it really simple. So which means I can go on the publish link over here.
Tulika, just to, I mean, add it if you feel comfortable. We can probably emit the OS version there in that message to see if we have that support of Ubuntu in that app service.
Oh, I'll show you the OS version in a different way. We don't
Okay,
need to
cool.
do that. Okay, so we're going to just publish to Azure, and again, I'm signed in with my user account, and it's the same user account I use for Azure, so it's just hopefully going to use that. You can specify, you can deploy your app on Windows as well, but right now I'm going to use Linux. And now it's picked up my subscription because I'm signed in using my account. So this is the subscription and this is the resource group. So I'm going to take my app from here. Again, with Visual Studio, see the create new button over here. So if you do the create new from here, from Visual Studio itself, you don't need to go and do the enable HTTP 2.0 and enable HTTP proxy, those settings. Visual Studio will automatically do this for you. So because we created the app on the portal itself, we had to do the settings over there. So I'm going to take, this is the service on which I want to set up.
While you're doing that, I think there's another question. Is gRpc replaced WCF in .NET Core?
I think that's a question for you, Nish.
Uh, so so yeah, I mean, not replaced, but as from Microsoft, you will see the everything is going to be on gRpc because again, it's open source and open protocols and things like that. So we will recommend always to use gRpc. But if you're someone, there are actually valid scenarios where you probably have a WCF application and you're looking for modernization and things like that. There is an open source project called Core WCF, which you can use, and that works on .NET Core. I hope I answered that question, Savan. Cool. Go ahead, Tulika.
So, I mean, I can't go ahead as yet because it's still doing the deployment. It takes a little bit because what it does is it takes your content, zips it up, sends it to Azure, unzips it over there, launches, compiles the code, launches your container. So it's going to do several steps and it hasn't finished yet. So I'm going to just leave it over there and come back to it a little later. So I promised you that we'll look a little behind the scenes about what does app service do. Remember we did that setting HTTP 2.0 proxy. Why did we need to do that? So this is what app service does behind the scene. So when you have a request which comes in from a browser or any kind of client, it first goes through the Azure load balancers, which is normal, but then it goes to something called the front end role. So app service, as I said, is a PaaS environment, but it has a number of roles associated with it. Ideally, you should only be worried about the worker role. The worker role is where your code resides, where you're going to run your app. That's what you are concerned with. However, internally for our infrastructure, we have to determine from the load balancer once the request comes in, which is your right worker. So you send a request to abc.azurewebsites.net, which is running on, I don't know, worker 256. Somebody has to tell us that now please go ahead and route this request, which has come in to worker 256. And that routing is done by the app service front end role. The front end role basically goes ahead and it has a config database. It reads the config database, and the config database has a mapping to which server is hosting which website. So it goes ahead and routes the request to that website. Originally, all the app service front end roles, these are all Windows servers, at least the front ends are. So the routing was done by IIS, which relied on http.sys, which is a kernel level driver on Windows, and it used a module called ARR, or application request routing, for forwarding the request. It uses WinHTTP in the background, and there were a number of disadvantages to this. Firstly, it was very Microsoft proprietary, which means ARR was a module which we maintained. It wasn't open source. It couldn't, and because it is WinHTTP, it couldn't take advantage of any of the modern things that were coming in, including HTTP2. So a team of engineers decided to work and modernize our front-end roles. And the way we try to modernize it is, firstly, we replace the web server by Kestrel. Now, that the .NET team has been working on Kestrel, which is open source, cross-platform, and much more performant than IaaS. So we wanted to take advantage of the work done on Kestrel. That was one thing. The second thing is, again, from the .NET team, we had YARP, or yet another reverse proxy, which was a toolkit which allowed you to create fast proxy servers. Now, if you think about it, ARR, all it's doing is a proxy. So it's taking a request and proxying it to the actual worker. So we wanted to take advantage of Kestrel and YARP, which was available because of the performance benefits. That was one thing, because when HTTP, we were getting so many, we get more than, I don't know, 1 billion requests per month, which is quite a few requests, and there is a huge performance cost, or there was a huge performance cost associated with it. We also wanted to light up new customer scenarios like gRpc for one, but a wider suite of SSL ciphers, custom error pages, which wasn't possible with the existing infrastructure. So therefore, we decided that we had to change our front-end roles from the IaaS http.sys ARR model to use Kestrel and YARP to make sure we are open source, to make sure we are taking advantage of everything with modern .NET provides. It was a big challenge. We have more than 200,000 dedicated cores, which is running the front-end role, and trying to transition it from an existing infrastructure to Kestrel and YARP was a big journey. It took over 6 months for us to finally do the transition. If you want to read a little bit about what our journey was over here, I've linked the article to it, and you can go and read about it. You can see a little bit on how we make sure that we followed SDP, or safe deployment practices. We try to make sure that no existing customers were affected. And right now we are in the state that 100% of all front ends on Azure App Services are using Kestrel and YARP. So that was a bit of a segue, and hopefully our app is deployed now.
Yeah, the link is, by the way, there in the chat. if anyone wants to explore that, whatever Tulika mentioned. So you can click on the comments, or you can watch the link on the screen right now. Tulika, do you want to take questions right now, or do you want to?
Yeah,
Is
sure,
it okay?
sure. Let's go ahead.
There's one question that I see on gRPC. I think most of the questions are on gRPC. If I guess correctly, gRPC only works on server-side technology, right? It will not work with browser-side JavaScript.
That is true for the moment. So most of the clients which are there right now, including the browser clients, do not do gRPC natively, which means that you would have to have special clients which make gRPC calls.
Yeah, but I think there's a gRPC web project, right? In
There
the
is
open
a
source.
just gRPC web project that, and in fact, Chrome, I believe, has an extension for gRPC as well. So you
Okay.
could natively call it, but it's not yet the default, if you will.
Okay. Cool.
Should we, any other question?
No, I don't see. I
No.
think we answered most of it.
Okay. So let's go ahead and browse our server, and I'm hoping this is coming from the cache. Okay, so our server is deployed now. It says your communication with gRPC should be from a gRPC client, because right now we are using browser as a client, and when we use browser as a client, we do, HTTP 1.1. So it's not a gRPC call. But the good news is we did have our client already created. So we had our client, and now Vivek, a question for you. What do we have to do to the client to make sure it works with
Change your
our server?
URL.
Yes, it's as simple as that.
Wow.
I was fast, no?
You're a very quick learner. Yeah.
That's all you need to do, because your server is now hosted. It has got the protocol buffer. It's got the service endpoints that it has. We've configured the service endpoint. Remember the port that we configured. So now all we need to do from the client is make sure it's going to the right URL. Also notice that I'm not passing the port in here. Remember that when I was doing localhost, I was doing :port because I wanted to connect to the port. And I'm not having to pass the port in over here because I set the app setting for HTTP 2.0 port. So which means my front end role is now going to look at this request, which is coming on 443 because it's HTTPS. It will say, oh, this app firstly, it is using HTTP2. So we assume it is using gRPC. We go and look at the client and we see, oh, the client is listening on port, whatever we configured. So I'm going to forward the request to Kestrel on that port. So now we can run this. And now you see that you're getting a hello response from the server, which is hosted on Azure App Service. But as far as your client is concerned, it just has to change your URL to find the right server.
Cool. That was quick.
So
Visual Studio makes it easy. Looks easy, no?
it is really easy with Visual Studio. I mean, again, you could do it by hand. So you could write all the code and add the service definition and do the NuGet install and make sure you have all the packages, but you don't need to.
Yep.
So just to recap, what do you need to do to run an ASP.NET gRPC server and client? You have to create, of course, you have to create your server or use the code and have an existing gRPC app and you can do the same thing. Make sure you create a Linux web app. Again, you don't need to create it from Visual Studio itself. You have the create new option and you can create it right there. If you create it right there, you don't need to do these settings, HTTP 2.0 and HTTP 2.0 proxy. Visual Studio will automatically set it for you. The only thing you'll have to do is create an app setting for HTTP 2.0 only port, because this is the port the front end is going to forward to Kestrel, because that's the port Kestrel is going to listen on. To finally deploy your app, and then you can test it with a gRpc client, and if everything works, you should get back a response. So
Cool.
I've already got the demo, and this is some links that I had in case Vivek will be handing out the PPT, I guess.
Vivek, you're muted.
I've posted most of these links in the chat, so it's
Okay,
not an issue.
okay. Um,
So
I
yeah, I
also,
mean,
and basically, as far as app services is concerned, this is uh, this is the article that we were following, which was how to deploy a .NET 7 gRPC. This is, I mean, this is for .NET 7, but I can post the links for .NET 6 as well as 3.1. 3.1 is out of support, so I don't recommend you creating an app, but if you have an existing app and you want to use gRPC on the existing app, you can do that. So as I
Cool.
was telling you earlier, Nish, I'm going to finish before time.
Um, yeah, that's true. How much time did we actually thought we will have this, Vivek? I don't recall now.
1 hour, but yeah,
Yeah,
6 minutes. It's okay. But
but but
Tulika
this is
was
a chat
asking me.
show. Yeah.
She was asking me not to ask this question in the back in the backstage. So I'm going to ask this question now. What's next? What's next after gRpc?
So I think
Yeah.
from a Microsoft standpoint, we are working to make sure that gRPC becomes the default as far as our microservice architecture is concerned. Microsoft has invested a whole lot into microservices, and you might have heard about, well, there is AKS or the Kubernetes, but you also have Azure Container Apps, and a lot of those apps are using gRPC by default. So we are trying to make sure we do have a lot of legacy systems which are still using WCF and REST API, but we are trying to modernize some of it and make sure that it uses gRPC going forward.
Right.
Perfect.
Awesome. Yeah.
Any
Okay,
questions?
folks. If you all have more questions, we'll be here for another 2-3 minutes. So please add them to your comments, and we can bring that up on the screen and ask Tulika. Um, so Tulika is a program manager on the App Services team. So if you have questions on the Azure App Service side of things more, well, we don't get her often, so it will be awesome to have her answer those those questions first. I know I don't know if Tulika, if you have heard this before in the past we used to get these questions a lot. Whenever we have the new .NET coming out, the app service we didn't have that support on the same day. Now
Yeah.
it's all changed. We have an almost the same day support right across
Day zero
uh,
support
day zero
across
support. Yeah,
all the board.
yeah. So all the cool
Cool.
things that you generally see in November and during .NET Conf time, it's something which you can actually take the code and right-click publish, and it's all available on App Service too. So which is amazing.
Also, we are working towards making sure that the monthly releases or the patch Tuesdays for .NET is available like within a week on
Cool,
app services. So, which means if something is released, it should be available almost immediately.
awesome. All right, I think with that, there's an amazing comment there. Thank you, Savan. He said it's really awesome session. So Tulika, there you go. We
Thank
have done a
you.
lot of sessions in the past, but we have not got these kind of comments. Uh, so thank you so much for coming in and helping us demystify gRPC for us.
Yep.
All right.
Thank you for being on the show, Tulika.
Thank
Thank
you
you
so
very much for
much.
coming here.
Bye then,
I learned
guys.
I learned a lot
You
today.
did.
Yeah. I mean, I learned specifically. I learned how to make changes to URL as well. Like, bang on, perfect. Yeah, perfect. Yeah, cool. Thanks for coming in. Thanks, Nish. Thanks, Pat. Thanks, everyone. We'll catch up again.
All right, see you guys.
Take care. Bye.